So I want to welcome you to the first webinar being put on by the Southern District of ITE's Workforce Development Subcommittee. And that subcommittee is part of the Member Services Committee. That's a mouthful, isn't it? Today's webinar will provide you with a general introduction to artificial intelligence as it applies to transportation. My name is Todd Brooks, and I'll serve as the moderator for today's webinar, and hopefully I'll do much better than I've already started out doing. Let me cover a few quick announcements before I introduce today's speaker. Obviously, you probably just heard today's presentation is being recorded. That's so that we had several people who were interested in attending today but had a conflict with this time. So this will be available for viewing later if we do things right. Um, Please, I don't think you have a choice on this, but remain on mute until the end of the presentation. We'll have time for questions and answers. And if you do have questions that you'd like to ask our presenter, please just drop them into the chat and we'll try to get through those questions at the end of the presentation as best we were able to do so. Question to come up about PDH certificates. We did not get that organized before this meeting, so we will not be sending out certificates for this particular webinar, but we do hope to do so for future webinars, so stay tuned on that. Also, we'd appreciate your feedback and suggestions for future webinars and training. The SDITE Workforce Development Subcommittee is currently conducting a survey. Some of you may know that if you read the SDITE connector, but we're looking to determine the types of training and topics that SDITE members would like to see. And the survey is open until December 23rd. And as a little bit of incentive, we are going to have a drawing of the people who responded for a $50 Amazon gift card. So maybe we won't be able to use it for Christmas shopping, but you can use it for after Christmas shopping if you want. I'll drop a link in the chat for that survey later as the presentation continues. And now I'd like to introduce today's speaker. Kevin Comstock's career spans over 40 years in the transportation industry. He currently serves as the Director of Transportation Systems with KCI Technologies, developing ITS and TSMO programs and assisting clients in drafting grant proposals and strategic planning programs. He previously served as the Smart City Director for the City of Chattanooga, Tennessee, Transportation Manager 2 with Tennessee Department of Transportation, and also as an ITS Project Manager for the City of Franklin, Tennessee. Each of his previous positions involved the design and construction of numerous transportation and telecommunications, with his specialties including project management, strategic planning, and collaborative team building. Kevin serves on the University of Tennessee at Chattanooga's Center for Urban Informatics and Progress, CUIP Advisory Board, and as the Technical Knowledge Chair for the Membership Committee of Southern District of ITE, and I'll also add he's part of Workforce Development Subcommittee. More importantly, Kevin and his wife of nearly 48 years spend much of their time with their 5 grandchildren and traveling, which I'm sure would make an interesting stories of its own. Kevin, we appreciate you sharing this timely information with us today, and I'll turn it over to you.
Well, thank you, Todd. I do appreciate it. And again, sorry this afternoon for the kind of hiccups we had here in the first beginning of this session. What I want to talk to you about today is artificial intelligence in transportation engineering. So that you know, and as a qualifier, this is a very basic ground level look at what AI can do within the industry. Give you some basic terms of stuff that we're looking at, and some use cases that are currently in place out there. I've given a copy of this presentation to Todd, who is given him the permission to go ahead and share it with anybody that might want it. Within the presentation, there are several links to some of the projects that we highlight, as well as some other resources. So please make use of those. If you have any questions, if you could just save them towards the end, and we'll try to respond to as many as we can. So to get ready, this is AI and transportation engineering. The agenda today is just a basic introduction, some of the branches of AI, some of the types of AI and transportation, challenges and threats, other resources, and then of course closing. So for an introduction to AI, we're going to talk a little bit about the branches of AI. The branches are individual, let's just say buckets of opportunity. Machine learning being the first uses the use and development of computer systems that are able to learn and adapt without following explicit instructions by the use of algorithms and statistical models to analyze and draw inferences from the patterns in the data. The second one we want to talk about is natural language processing. Uses machine learning to enable computers to understand and communicate with human language. Let's think things like Alexa and Google Nest and those types of applications. Neural networks are a computational model that mimic the complex functions of the human brain. Robotics is a branch of artificial intelligence that involves designing, constructing, operating, and using robots to perform tasks traditionally done by humans. Any number of manufacturers, Amazon, package handlers, that type of application. Computer vision is the final one here, the branch of AI. Computer vision uses machine learning and neural networks to teach computers and systems to derive meaningful information from digital images, videos, or other visual inputs, and to make recommendations or take actions when they see or detect certain issues. From transportation perspective, computer vision we use pretty frequently now for incident detection, using CCTV cameras, using some of your detection, roadway detection information, kind of glean the system to understand that traffic is moving or isn't moving, and what it can actually see through the video picture. So moving that a little bit further, the different types of AI are kind of categorized in two different buckets here. The first one's based on capability, and the second one based on functionality. When we talk about capability, the first one is the narrow or weak AI. Traffic signal control systems, the AI algorithms optimize traffic timings to reduce congestion, improve traffic flow. Also, areas that we can utilize this is in predictive maintenance. AI models can predict when transportation infrastructure, like bridges and roads, need maintenance to prevent failures and reducing cost. So there's good technology behind it that helps aid us in those types of things. General AI is a system that generalizes human cognitive abilities, capable of performing an intellectual task that any human can. This is still theoretical and doesn't exist, although I'll qualify that at the time that the information I gathered for these for this presentation, that's kind of the fact. There is a lot of work in this area currently, so I don't want to say that it's not doesn't exist yet. It would be this type of AI would be the type that can understand, learn, and apply knowledge from across a wide range of tasks. And then the next one is super intelligent AI. AI that surpasses human intelligence across all fields, including creativity, general wisdom, and social skills. This really gets into the artificial intelligence where they start to become more creative. You could ask them to paint pictures. You could ask them to write poetry. Any number of topics that would be more of a creative factor than a data-driven response. This is also theoretical and the topic of much debate and speculation in AI research. How much do you actually use this for? And this is probably one of the areas where AI is most problematic in how government agencies and others look at AI, look at the technology as a whole. So moving on to the functionality side, um, types of AI-based in functionality is reactive machines. We can think about these as autonomous drones, things that could be used for inspecting infrastructure. These drones react to their environment in real time, but not learn from past flights. So they could do things like evaluate bridge structures and look at certain things that they're programmed to look at or take pictures of, let's say. Um, Automated toll collection systems that detect and charge vehicles as they pass through toll booths without retaining data for future use. These are a couple of applications that we in transportation could potentially see in the near term or may have already been experiencing. Um, there is the next one is limited memory. Things like self-driving cars, the vehicles that use data from previous trips to improve their navigation and decision-making capabilities. Things like adaptive cruise control. That's a system that adjusts the vehicle speed based on the behavior of the surrounding traffic using data from past interactions. Um, so these types of technologies are present now. And as you look at the automotive industry, a lot of these features are already on vehicles, and we're starting to see this permeate the market in a much larger scale. Theory of mind is the next type of AI. Human machine interaction systems, AI systems in development that aim to understand and predict driver behavior to enhance safety features in vehicles. Another pathway for this is advanced traffic management systems. These systems could predict and respond to human driver behaviors to optimize traffic flow. So rather than based solely on data points, it can actually evaluate individual drivers and the vehicles that they're in on how they're moving through the network and be able to project or predict how that vehicle could navigate through a system more safely and more efficiently. Further opportunities include self-awareness. This is the Skynet Terminator type activity where the systems become self-aware of themselves. AI systems that own consciousness, their self-awareness and understanding of their own existence. Currently, fortunately, this is purely theoretical and does not exist in any platform that I'm aware of at this point in time. But it is important to know that in the evolution of AI, even in the past 5 to 10 years, it has made tremendous jumps in technologies and abilities. And it wouldn't be out of the realm of possibilities to see self-awareness becoming something in the next maybe 5 to 10 years. There's not a whole lot of agreement on where that happens, and there's a tremendous amount of governance that needs to be in place before that's fully evolved. So moving on, we're going to talk about AI in transportation. These are some specific examples of some projects that are out there where AI is being utilized in support of different things. Initially, I gave you that graphic that kind of indicated the 5 different buckets of machine learning and natural language based and so on and so forth. The one thing about AI in this is that even though you have these individual buckets can all work in some manner together. In Chattanooga, this is a project that I was directly involved with. The this multimodal decision support system was a project that we envisioned in Chattanooga and utilizing the smart Martin Luther King Smart Corridor and researchers from the University of Tennessee at Chattanooga, University of Pittsburgh, Georgia Institute of Technology, Oak Ridge National Labs, along with the city of Chattanooga. We're working in collaboration to implement a project that aims to develop a dynamic adaptive traffic control system. What that would do is was looking at was a reduction of corridor level fuel consumption by 20% while maintaining safe and efficient transportation operations. In addition, the system would facilitate the management of electric vehicles to link them with charging opportunities, considering a couple of factors: the state of the transportation system, the availability of charging stations, and the state of electrical distribution grid, and the health of its assets. And then finally, the EV user needs, like fast charging or other types of charging. This project was submitted to the Federal Highway Administration for an ATC MTD grant back in 2022 and was awarded $4.75 million to move forward with this project. But some of the features of the corridor, and this is because we had the existing corridor in place, in the picture that we have here on the screen, we had deployed most of these technologies at several of the intersections along that corridor. It's a corridor of about 12 intersections. It was in the urban core of Chattanooga, Tennessee, ran directly in front of the University of Tennessee at Chattanooga, the Center for Urban Informatics and Progress, and through the fiber optic network system. Both the university and the city were able to monitor the systems that were out there. And the concepts behind this were to create basically a living laboratory where certain tests and environmental opportunities could be operated or run on this test bed and understand what it would be like in the real world in a controlled and somewhat controlled environment. So that was just one use of AI in the overall context of what is possible. So moving on, uh, further current uses of AI in traffic management. Several agencies across the country have been using ATSPM, the Advanced Traffic Signal or Automated Traffic Signal Performance Metrics measures. This is a technology that looks at the traffic signal controllers, gleans a tremendous amount of information, detector systems, how the signal is operating, arrivals on green, arrivals on red, and monitors this situation. This particular photo on the left is a visual representation of what that dashboard looks like that is provided by the state of Georgia in their DOT. Utah has one that's very, very similar based on the same application. A few years ago, Purdue University and several in Indiana worked on the ATSPM and these types of advanced or automated traffic signal performance measures to kind of understand operationally how a signal is operating. Certain things that it could look for is detector failures or problems within the detection systems, and how best to predict those types of things and promote them or make notice of them to the professionals utilizing the system. So they had the opportunity to go out and fix or try to repair whatever the problem was. This is key in a TISMO type application about making sure that the equipment and the effectiveness of the equipment is kept up with so that it performs at its peak level at all times. The second one is City of Pittsburgh, Pennsylvania, uh, also was granted an ATC MTD grant for something called the Smart Spines. Now, this was an effort in Pittsburgh to develop a very robust telecommunications network and set of systems within the urban core of the city. The spines aspect of that was several of the corridors leading into the city core, of course, had their traffic signal systems and went through multiple metropolitan or agencies between or jurisdictions between the beginning points in the downtown core. This was an effort to try to coordinate and work actively in aggregating systems that could operate together and help build this better performing system overall. We at KCI were involved in this particular project to the point where we were able to help with some of the determining the technologies that got deployed and how best those technologies work with other technologies and those sorts of things. Very groundbreaking work in Pittsburgh, and it's a good effort there. So moving on, we'll talk about the current use case of incident detection and management. The Nevada Department of Transportation, in partnership with Nevada Highway Patrol and the Regional Transportation Commission, are using artificial intelligence software to alleviate traffic crashes at dangerous intersections with a higher than average crash rate in Southern Nevada, primarily the Las Vegas, Clark County area. The system uses connected vehicle data, existing cameras, roadside sensors, and other traffic-related data to develop predictive analytics that could be used to recognize traffic patterns associated with crash-related congestion. These detected traffic patterns then enable traffic management professionals to enable countermeasures or to implement countermeasures to improve safety, such as increasing police presence in areas where speeding vehicles and improving response time for emergency vehicles by detecting incidents sooner. As you can see in this, the post-implementation testing indicated that there was an average of 12 minutes sooner for emergency vehicles. And over a period of a year after this system was implemented, they said it contributed to a 17% reduction in primary crashes. This is all good work. This is a particular software application that is being utilized to perform this activity and grasp that information. I'm not going to go into who it is, but also understand that there are a number of other organizations, companies out there that have similar type technology platforms that can do many of these same things. So it's not necessarily a one size fits all. There are many different organizations that can help look at and develop systems that will work specifically in areas that you may be working with. Another current use is asset management and maintenance. We touched a little bit on this with the ATS PM data. This particular one was a study that was performed by Brigham Young University along with the Utah Department of Transportation. I don't know if any of you know Blaine Leonard. Very innovative, been very active in this space for a number of years. I've known him probably close to 10, and he's been pretty active in it the entire time, even before that. But this research was considered some of the first known study to detect traffic anomalies and provide automatic statistical method to detect anomalies in the data. It's an important subset of machine vision applications that an AI system can address the operation, maintenance, and improvement of physical assets. And it's very crucial to agencies to achieve this and desire, in their desire to have their equipment, their systems in a good state of repair and operating throughout the life cycle of those assets. It's more economical, provides greater benefits, and a fully functioning system over time is a better way to move forward for most of these or for all of these agencies. AI has the potential to improve transportation systems through better monitoring and management of assets and to keep infrastructure in proper condition. ATSPM continuously collects detailed data of the traffic signal performance, like vehicle delays, queue lengths, detector malfunctions, providing insights into the health and efficiency of the signal system. This is a pretty well thought out process, and most of the agencies, as indicated earlier in this presentation, Georgia, Utah, Several other states have adopted the ATS-PM platform, and most of this information you can work with those agencies and help develop your own. Should your agency not currently take advantage of that, this usually requires a modification to the field equipment, upgrading software or whatever. But this is something that is easily obtainable and provides great insights over time on the health and welfare of your network. Another great use of AI is for safety enhancement. This gets back to that video learning system. Um, the city of Bellevue, Washington, performed a study where, as part of their Vision Zero project, they partnered with a private industry to eliminate fatalities and serious injury crashes by 2030. A part of that strategy included identifying which intersections had the most problematic in terms of crashes. Bellevue did not have the volume or granularity of data to accurately identify intersections that required immediate attention. Traditional methods were unable to identify near crashes, classify road user types, or detect speeding infractions and lane violations. We did something similar to this in Chattanooga when I was talking about the smart corridor that we built there. Basically, through the use of technology, we could identify a lot of different users. This particular application in Bellevue uses video technology and to be able to uh, identify certain objects within the roadway. And as you can see in this particular photograph, proximity awareness, which is crucial to near miss activity. What we found in Chattanooga when we did a similar type activity was the only time that we ever found out about accident or crash statistics with pedestrians or bicycles or when they actually occurred. We didn't know how many near misses that there were out there and how we could actually utilize some of the technology that was available to start to aggregate some of that information and determine safe distances between objects in an intersection. It also gave us some operational ideas about things like leading pedestrian intervals and yield for permissive left turn traffic that could be opposing to a pedestrian movement. So there's tons of different technologies that could be pulled together to combine and get you the answers that you want in the format that you need them to make decisions like Bellevue was on the granularity of the information and to be able to look at the different intersections and be able to program responses to that is an easy way to start to qualify a priority list of where your high impact network was. Now, this particular topic, complete street initiatives, is something new. I've only found out about this since February of this year. Dr. Robert Hampshire is the Chief Science Officer with um, at Federal Highway ITS Joint Program Office. Um, they're starting to utilize AI in the design and implementation of complete streets initiatives, how best we can start to look at some of those things. In some cases, basic roadway data such as traffic volume and presence of sidewalks is unavailable or incomplete. In other cases, data can be skewed demographically. To close those gaps, they were encouraged to create methods to develop national data sets using novel and scalable approaches to data science, such as utilizing big data, Internet of Things, artificial intelligence, computer vision, and machine learning to a range of data sources that and types that may include satellite, aerial, and street level video and still photography um, at street level, sensor based and crowdsourced data, vehicle probe data, telemetry, including shared micromobility and transit modes. So there's all sorts of different resources available to start to pull together and have these systems, if the algorithms are developed properly, have these systems start to learn how to look at certain things in the environment and develop solutions that can help mitigate certain activities, whether it's crashes, just comfort level, or to be able to manage traffic. So the next step is probably one of the more interesting aspects of AI and what we view as some of the challenges and threats of this technology. So to get into that, a lot of what we're seeing right now is in the areas of data privacy, security, cybersecurity is a big issue, and then of course the ethical considerations. Those are probably some of the top ones that for elected officials they think about in the overall use of AI in what we do currently. Um, but there are other facets to this. There's a relatively high implementation cost initially. Is the system reliability and public trust of the systems? And then the big one that I work with on a pretty regular basis is the integration of these new technologies into legacy systems. Those are some of the bigger challenges that we have in the industry today. We can go out and throw out all kinds of new equipment and hardware in the field, but integrating that stuff back into your system can sometimes be a problem. And that's why it's important to do your systems engineering analysis and think through these processes to make sure that you're getting the product or putting the product out there that you need and will actually help you collect the data and do the things that you want to do. Now, with regard to data privacy and security, and along with the cybersecurity threats, um, working collaboratively with IT departments and specialists within your organizations about governance of these issues or the how what policies are written and how they're directed, who has access to the data, how it's transferred or shared between yourself, between agencies, are going to become bigger pieces of the puzzle as we move forward in this space. We've already started to see some challenges in those areas, and this is an area where there's a high value for bad actors to come in and carry on nefarious acts within our infrastructure. These are some of the things that keep us awake at night, as they should. And we need to be cognizant of these types of technologies and put forth our best effort. Um, in Chattanooga, we always tried to use what the current DoD Department of Defense uh, status was on various technology and the accessibility to that. But we still had a long way to go in the government governance and the sharing and warehousing of the data, how that got managed. Ethical considerations is the automated decision making part of AI that can lead to ethical dilemmas. Everybody's made that comparison between a bus full of kids and a single elderly person in a vehicle if they were to crash. Well, theoretically, with AI and the technology that's being developed, we should never actually get to that point, but it is a concern. And so we have to be cognizant of that also. Public trust in the systems, that's going to be an ongoing thing. People are kind of naturally have a little bit of an avoidance for some new technology sometimes. But if you've noticed across the industry with vehicles and some of the computer technologies, cell phone technologies that are out there right now, they're slowly, incrementally making these improvements or introducing these new technologies. I can remember not that many years ago where side collision avoidance systems or side swipe systems, lane maintenance systems, were just groundbreaking and not new. And pretty much every vehicle that's made now has some sort of variant of those types of things. So it's a slow introduction of the technology to build that trust and to improve the reliability of those systems that can test and theorize and retest again. Um, so we'll close it at that point as far as the threats and challenges at this point. But we do want to move forward here. So next slide. This is some of the other resources that I ran across. Again, if you ask for a copy of the presentation, you'll have these web addresses to do some of your own research. I'm sure that I put this together in a couple of days. I am sure there's probably a half a billion other resources out there with differing opinions on things. But for the totality of this briefing and in transportation specifically, I just kept it to the ones that kind of made sense to talk about within this context. So, final thing that we need to think about is AI moving forward. Um, One of the big things is AI tends to improve efficiency, safety, and sustainability. Through some of the use cases that we went through, particularly with collision avoidance and incident detection, that can be easily measured against this improved efficiency, safety, and sustainability. Um, AI optimizes traffic flow, predicts maintenance needs, and enhances safety through real-time data analysis. Again, points towards the ATS-PM technology that is currently available and is only being enhanced over time. Applications such as CAV, ITS, and predictive maintenance can reduce congestion, extend infrastructure lifespan, and minimize human error. These are big factors in some of the cost discussions that we have and the impacts to society, cost benefit type consideration when we start to talk to our elected officials about introducing some of these types of technologies. And then the benefits of the technology should outweigh many challenges like data privacy, cybersecurity, and high cost. As we deploy these things and become more familiar with the systems, we can build the governance and the policies around these things. We can build the data sharing agreements and other types of technologies. These are the currencies of the future, and these are the things that we're going to have to learn how to do to be proactive in this space. I think gone are the days where each individual agency sets up their own system and doesn't necessarily communicate with anybody external to their city or their agency. Um, in the environment today, most people don't know when they cross jurisdictional lines, and you're starting to see that with some of the projects like the regional traffic RTOPS, I think it was called in Georgia, where they're doing an integrated corridor to a sense, the I-24 integrated corridor in Tennessee. Even that Pittsburgh Smart Spine technology kind of worked on that principle. That a corridor, the system should operate irrespective of what the jurisdictional boundaries were. And so with that, this is my contact information, and I'm definitely open to any questions should somebody have some.
Kevin, I don't see any currently in the Q&A or chat, so you must have covered everything very thoroughly. I'll wait another minute or two while that's going. If you do have some questions or for Kevin, you can pop them in and using the Q&A feature if you want to, or I am monitoring the chat as well. Um, just in closing, Kevin, first of all, thank you so much for spending time today to provide us a brief overview of this topic. I know it's one that we hear a lot about, and I'm sure with the numbers of people on the call, we have a wide range of people with various understanding and of the topic. Um, we do hope that this has provided the participants a fairly good introduction and an overview of AI as it applies to transportation engineering. Just trying to scratch the surface, really. and enhance your understanding a little bit of that. We will make this available later on. I do see a question coming up here. Let me read this one. Kevin, what do you see? You may be able to read this too, but I'll read it out loud. What do you see in the future with AI once quantum computing picks up? And how would that complement or challenge AI?
I don't, well, personally, in Chattanooga, we had the opportunity. We don't publicize it that much, but I am aware of quantum computing. And I think overall in the industry, with the level of data that we're going to have to try to manage once we start talking about connected vehicles and autonomous vehicles, all of these integrated systems, we're going to need to use quantum computing to help process that in a far more rapid and distillation of the data that comes in. Quantum computing is a complex computing method. It's completely outside of anything that we know currently. But I do know that they can process, and the security of the system is tremendously much more broad and enhanced. I think that quantum computing is going to help us in discovering new horizons into the future. Um, I'm an old guy, so I don't know that I'm ever going to see this, but I think that the potential is there to be the transitional piece that we need to be able to make this very complex, connected, and autonomous environment work.
Thank you, Kevin. I don't see other questions right at the moment. So let me do another couple more closeout announcements. Just to let you know too, obviously this just skimmed the surface of AI. We've been discussing taking a deeper dive either on one of the projects that Kevin highlighted, perhaps getting one of the speakers from that can address one of those particular projects that he pointed out. Maybe do that in a future webinar, or just one of the individual concepts or topics in here, and taking a deeper dive in that, because I know today was very, very general in nature, and as it was intended to be. So if that is something of interest to you, please reach out to Kevin or myself and let us know that. We'll pass it on to our committee as we plan our future webinars. The other thing I did mention again, I'll just reiterate that we do have the survey for SDITE members that's out there. I did drop that finally when I figured out how to do it to everyone. I sent a link out. Kevin got tired because I sent it twice in a row to just him and me. But I did send it to everyone. There is a link to our survey. It's also in the SDITE connector. That survey is open until December 23rd. And again, the $50 Amazon gift card could be yours if you participate in that. But that will help us know what topics of interest are of interest to you, so that we can tailor the content of this webinar and future training that we do throughout the coming year for SDITE, what you'd like to hear us talk about or like to learn more about, or even if you want to volunteer to talk about one of those subjects, we would certainly welcome that. So let us know through the member survey if you get a chance. And I'd be remiss as an SDITE member if I also did not promote the SDITE 2025 annual meeting. It's going to be in Memphis, Tennessee, April 13th through the 16th. So just mark that on your calendars. I don't recall whether registration's opened up yet or not, or open up after the first of the year. So sorry for that. I don't see any more questions or comments. Kevin, do you have any closing remarks?
No, I appreciate the time. And this is a complex thing, and I tried to break it down in easy, digestible pieces. It was, again, by no means an overall comprehensive review of the industry as a whole, but we did want to try to get this out there and put this together in a format that was easily understandable by our members.
Very good. Actually, wait a second. I do see one more comment up here. Oh yeah, just a comment. Okay, just a comment. That's fine. I did drop my email in the chat as well. I think it was in the announcement for the webinar, so you should have it both ways. If you need to communicate to me directly, feedback or requests for the presentation, If you'll forgive me, I'm not sure exactly how we're going to disseminate the recording from today's meeting and the presentation. We'll get back with you on that. But if you are interested, let us know, and I'll try to keep track of all that for you. And I appreciate your patience today and apologize again for the late start. As we learn this, we'll get better as we go along throughout the coming year. And I appreciate everybody's participation today. And I think I'm going to look one last time and see if there's something else here. I think there may be. Yep, just thank you. Very good. Thanks everybody for being here today, and we appreciate your participation.
Thank you.
All right, bye.